kilopascals, we're given pressure, we're given temperature, we're given a second temperature, T2, and we're asked to solve for a second pressure. We're given T1 and P1 as well. We'll start with the ideal gas law, which states pressure times volume is equal to the number of moles times the universal gas constant times the temperature on the Kelvin scale. What you can do is move all the variables to one side and all the constants to another side. So in this problem, pressure and temperature are the variables. So let's move all the variables to the left side, which are P and T. We can divide through by T to get T over to the left side. And let's move all the constants to the right side. Volume is constant. The number of moles is constant. And R is defined as a constant. So we can move volume over to the right side by dividing through by volume. So what we have is P over T is equal to NR over V. And the right side are all constants. They're numbers that do not change. What that means is any combination of pressure and temperature of this gas is going to remain a constant. And as we can see, pressure is proportional to temperature. In other words, P1 over T1 is equal to P2 over T2 is equal to P3 over T3, and so on. This is known as Gay-Lussac's law. Before we start, all our values need to be on absolute scales. So we need to convert all the temperature values from Celsius to Kelvin. We can do that by adding 273. Next, we can rearrange Gay-Lussac's law to solve for the desired variable, which is the final pressure. Now we can plug in our values. P1 is 1000 kilopascals. T2 is 323 Kelvin. And the initial temperature, 293 Kelvin. Kelvins cancel out, and our answer will be left in units of kilopascals. Our answer should have three significant figures because all the measurements given have three significant figures in their absolute scales. So P2 is equal to 1.10 times 10 to the 3 kilopascals.